to start this problem here, number 53, let's factor that denominator. There's an x in both terms here, so we'll take an x out. We'll be left with x minus 6 equals 1 over, now we've got the difference of two squares, right? X squared and 6 squared. So here's our parentheses. We'll have x and x. 6 and 6 will make 1 plus, 1 minus. And now we can see that the LCD here is x, right? We get that x right here. X minus 6, right? We have an x minus 6 here and 1 over here, but it's just to the first power, so we need only 1. And then we have this x plus 6, so we'll include that. So let's get that. Now let's check for excluded values. So what values do we have to exclude? Well, x cannot be 0, it can't be 6, and it can't be negative 6. So let's write that. Let's indicate that. X cannot equal 0, 6, and negative 6. I'm going to circle that so I can find it at the end. Now our process is to write this LCD alongside each one of the original terms. So we'll put it here, and we'll put it here. It looks like it's going to be a little bit long. You know, I'm going to do this up here. So here's what we'll get. We're going to get 2 over x minus 6 times x minus 6, x plus 6 equals, and now we'll put the LCD right here alongside that one. So we'll get 1 over x plus 6, x minus 6 times the LCD, x minus 6, and then x plus 6. Now all these denominators should cancel, right? That x times x minus 6 will cancel with that one, and we're going to be left with this 2 times that x plus 6. So let's write that. We'll get 2 times that x plus 6, that's what's left after we cancel, equals, now over here, these two factors will cancel, and we're left with 1 times x. Let's cancel those. Those go out, and we're left with 1 times x, which is just x. Now, we've taken this original equation involving rational expressions and just converted it to an equivalent one, but just one with no fractions. Pretty easy to deal with this, so let's do this. This is going to give us 2x plus 12 equals x. Now what I'm going to do is I'm going to subtract the 2x from each side. You could subtract the 12 and then subtract the x, but we could easily subtract the 2x. So if I do that, I'm going to end up with 12 equals, now x minus 2x is negative x. And then I'll just divide or multiply both sides by 1. I'll get negative 12 is equal to x. So I think I've got a solution, but I need to check, right? We need to check this. Is it excluded? So let's go all the way back over here. Here's our excluded values, 0, 6, and negative 6. We're getting negative 12. So this is not excluded. So now we can claim that x is negative 12, that negative 12 is the solution to this equation. So in this problem, let's start by factoring this denominator over here. So we're going to get 9 over x plus 5 plus 2 over x minus 5 equals 20 over, what do you know, x plus 5, x minus 5. That's a surprise, isn't it? Now look at the LCD. The LCD is going to be this x plus 5, x minus 5. And our excluded values, right? What numbers are going to make these denominators 0? Well, we can tell right from here. Change the signs, right? Negative 5, 5. So let's indicate that. X cannot equal negative 5 and 5. I'll circle it so I can find it here at the end. Now, let's write this LCD alongside each one of these 3 original terms. We're going to write it here, here, and here. Gets a little long, but let's do it. So we're going to get, see if I can write it, 9 over x plus 5 times the x plus 5, x minus 5, plus 2 over x minus 5 times the x plus 5, x minus 5 equals 20 over x plus 5, x minus 5 times that x plus 5, x minus 5. Now all these denominators are going to cancel. So let's do this. We'll get this x plus 5 canceling that one. So we're left with this 9 times x minus 5. So we're going to get 9 times x minus 5 plus, now what happens here? This x minus 5 will cancel with that one. Let's do it. That cancels with that one. And we're left with this 2 times the x plus 5. So we're going to get 2 times the x plus 5 equals, now on this side, this denominator completely cancels with that multiplier. So let's cancel that. This goes here, and we're left with 20 times 1, which is just 20. So let's finish this up. We're going to get 9x minus 45 plus 2x plus 10. This is all equal to 20. And then we've got 9x's and 2x's. There's 11x's. Negative 45 plus 10 is negative, or minus 35 in this case, equals 20. Let's add 35. We'll get 11x equals 20, and 35 is 55. Dividing by 11, we'll get x equals 5. But now, as we always do in these rational equations, we need to check to see if this is excluded or not. So we follow it all the way back up here, and sure enough, 5 is an excluded value because 5 is going to give us division by 0 here and here. So it's excluded. That's what we got for an answer. We have to toss it out, and we don't have anything else. So we're going to say this equation has no solution. But the way a lot of textbooks write it is just write the Greek letter